Good morning dear students, this is Bonani Borkasto. I welcome you all to today's video. Here we are doing the chapter Matrices. So we will start with question number 18 of exercise 3.2. So see question number 18. If A equal to a 2 by 2 matrix is given 0 minus tan alpha by 2, tan alpha by 2, 0 and I is the identity matrix of order 2. Show that I plus A is equal to I minus A into cos alpha minus sin alpha, cos alpha. So for that we will start with the identity matrix I. So we have written I here, which is a 2 by 2 matrix and identity matrix. So 1 0 0 1. Then I plus A will be, here we have written the identity matrix and here it is A. So we have added the corresponding elements of I and A. So it will become 1 minus tan alpha by 2, tan alpha by 2, 1. Next we have done I minus A for the right hand side. So I minus A means identity matrix I minus the matrix A. So here we subtracted the elements of A from I. So it will become 1 tan alpha by 2 minus tan alpha by 2, 1. So all are 2 by 2 matrices. Next we will start the calculation from the right hand side. So this is the right hand side. I minus A, we have written the matrix I minus A, which is 1 tan alpha by 2 minus tan alpha by 2, 1 and cos and the matrix cos alpha minus sin alpha, cos alpha. Now we will multiply these two matrices. So here is the multiplication of two matrices. The first row is multiplied by the first column to fill this one. The first row is multiplied by the second column to fill this one. In this way, the second row is multiplied by the first column to fill this one and the second row is multiplied by this second column to fill this one. So this is cos alpha plus tan alpha by 2 sin alpha. This is minus sin alpha plus tan alpha by 2 cos alpha. This is minus tan alpha by 2 cos alpha plus sin alpha. This is tan alpha by 2 sin alpha plus cos alpha. Now we will do the calculation to equate it with the left hand side. So for that we have written cos alpha as cos 2 alpha by 2. So it will again become cos alpha if we cut these two 2's. Here we have written tan alpha by 2 sin 2 alpha by 2. So it is in place of sin alpha. Minus sin alpha is replaced by minus sin 2 into alpha by 2. Here this cos alpha is replaced by cos 2 into alpha by 2. In this way, for the second row also we have replaced here cos alpha, sin alpha and sin alpha, cos alpha, so that we can apply the formula of cos 2x and sin 2x. So here we have done the rough. So this is the element of first row, first column. Here in place of this we need 1. So for that we used 1 minus 2 sine square alpha by 2 in place of cos 2 alpha by 2. This is the formula of cos 2x, which is 1 minus 2 sine square x. And we have written 2 sine alpha by 2 cos alpha by 2 in place of sine 2 alpha by 2. This is the formula of sine 2x, which is 2 sine x cos x. Now tan alpha by 2 can be written as sine alpha by 2 by cos alpha by 2. And after that we can cut cos alpha by 2 and this cos alpha by 2. From there we will get 2 sine square alpha by 2. And from this line we will get this 1. Now this is the element of first row second column. Here we have replaced sine 2 alpha by 2 by 2 sine alpha by 2 cos alpha by 2. This is the formula of sine 2x. Next, here we have replaced this cos 2 alpha by 2 by this formula, which is 2 cos square alpha by 2 minus 1. See, now we have multiplied this tan alpha by 2 and 2 cos square alpha by 2, tan alpha by 2 and minus 1. After that, from here, tan alpha by 2 can be written as sine alpha by 2 by cos alpha by 2, and we can cut cos alpha by 2 and from here cos alpha by 2. So we will left with this 2 sine alpha by 2 cos alpha by 2. After that we will get this minus tan alpha by 2. In this way, for other two elements also we can do in this way, and we have put the values in the matrix in place of the corresponding elements, and we have our this matrix. So this is equal to the LHS. So in this way we can show I plus A is equal to I minus A into the matrix cos alpha minus sin alpha, cos alpha. Now come to question number 19 of exercise 3.2. In question number 19 it is given that a trust fund has 30,000 rupees that must be invested in two different types of bonds. So we have 30,000 rupees and we have to invest this 30,000 rupees in two different types of bond. And how much rupees is invested in which bond, it is not defined here. Now in the next line it is written that the first bond pays 5% interest per year and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide rupees 30,000 among the two types of bond. If the trust fund must obtain an annual total interest of, first question is rupees 1800. So here we have 30,000 rupees to be invested in two different types of bond. First bond pays 5% interest, second bond pays 7% interest. Using matrix multiplication, we have to determine how this 30,000 is divided among the two types of bonds. If the trust fund must obtain an annual total interest of rupees 1800. Total interest means the interest we will get from both the bonds. Now let us see the solution of question number 19a. So here is the solution of question number 19. A, this is the solution of A. Let X be invested in the first bond. As we don't know how 30,000 rupees is divided among the two bonds, and rupees 30,000 minus X is invested in the second bond. So from this X and 30,000 minus X, we will get the total amount is rupees 30,000, which is invested in both the bonds. Now we will represent this information in matrix form. So we have denoted the matrix by A, and we have written X and 30,000 minus X in this way. And we have written the matrix as a 1 by 2 matrix, where we have one row and two columns. We can write A in different way also, we will show it later. Next, the first bond pays 5% interest per year, it is given, and the second bond pays 7% interest per year. These two things are given. So we will represent this information in terms of matrix. So we have denoted the matrix by B, and since we have represented matrix A as a row matrix, we have to represent matrix B as column matrix. Otherwise we cannot do the calculation. Remember this one. What is row matrix? In which matrix we have only one row, and what is column matrix? In which matrix we have only one column. So here we have only one row, and here we have only one column, so that we can get our answer. Now see, to multiply these two matrices, the question is we will find AB or BA. For that, see, A is a matrix of order 1 by 2 and B is a matrix of order 2 by 1. Where AB, if we find AB, then it will be of order 1 by 1. 1 by 1 means one row, one column. That means if we find AB, we will get a single element, and we will write the single element alone without the symbol of matrix. And if we find BA, then this BA matrix will be of order 2 by 2. So 2 rows, 2 columns. So with that BA, we cannot do our calculation. So we have to find that matrix which will give us a single element, and that matrix will be AB. So here we are finding this AB, and we have multiplied this row with this column. So X will be multiplied by 5 by 100. 5 by 100 means 5%. 5% can be written as 5 by 100. So it will become 5x by 100, and 30,000 minus x will be multiplied by 7 by 100, which is 7%, and it will become 30,000 minus x into 7 by 100. Now according to question, our annual total profit is rupees 1800. So here AB will be equal to 1800. So on the left hand side we have put our AB, and from there we can find X is equal to 15,000. You can do this calculation yourself, so I have not done the calculation here. So in this way we have to do question number 19. Now I am showing the another way to do question number 19, where we will represent matrix A in the form of column matrix and matrix B in the form of row matrix. So this is the portion where I have represented matrix A in the form of column matrix and matrix B in the form of row matrix. Now here also the same question arises that we will find AB or BA. I told you earlier we have to find that matrix from where we will get a single element. Now see, if we find AB as, see here we have found AB, but whenever we will represent matrix A and matrix B in this way, if we find AB as earlier we have found AB, then AB will be of order 2 by 2. See, from here AB will be of order 2 by 2, and from AB we cannot get a single element. So here we have to find BA so that we can get a single element and it will be of order 1 by 1. So in this way we have to do question number 19. Question number 19B is same as question number 19A. So I think you can do question number 19B. Let us move to question number 21 of exercise 3.2. So for question number 21 and 22, these lines are given. Assume X, Y, Z, W and P are matrices of order 2 by n, which is the order of matrix X, 3 by K, which is the order of matrix Y, 2 by P, which is the order of matrix Z, n by 3, it is the order of matrix W, and P by K, it is the order of matrix P respectively. Choose the correct answer in exercises 21 and 22. So here question number 21 is the restriction on N, K and P. We have to find the restriction on N, K and P so that Py and Wy, Py plus Wy will be defined. Here is the solution of question number 21. Matrix P is of order P by K, matrix Y is of order 3 by K and matrix W is of order n by 3. Since Py is defined, so it will be of order P by K. That means Py is defined means we can find Py. So order of P is P by K, order of Y is 3 by K. So since Py is defined, Py will be of order P by K and K must be equal to 3. Now since Wy is defined, that means we can find Wy. So it will be of order, Wy will be of order n by K. Now see, here W n by 3 and Y 3 by K. Here 3 and 3 are the equal. So number of columns of W is equal to number of rows of Y. So Wy will be of order n by K. Since Py plus Wy is defined, that means Py plus Wy we can find. Whenever we add two matrices, their order should be same. So the order of Py must be equal to the order of Wy. Order of Py is P by K and order of Wy is n by K. So they must be equal. So P by K is equal to n by K. From here you see K and K both are same. Since these two things are equal, N must be equal to P. Then only these two things will be equal. So P is equal to N. So we have our answer. First one is K is equal to 3 and second one is P is equal to N. So our answer is option A. Now come to question number 22 of exercise 3.2. In 22 it is given if N is equal to P, then the order of the matrix 7x minus 5z is. We have to choose an option from these given options. So here we have done our calculation of question number 22. So question number 22, matrix X is of order 2 by n which is given. Then order of 7x will be 2 by n. See, since order of matrix X is 2 by n, and if we multiply this x by a scalar which is 7 here, then the order of 7x will not change. It will be same as the order of x which is 2 by n. Matrix Z is of order 2 by p, and if we multiply Z by 5, then the order of matrix 5Z will be same as the order of matrix Z, and the order will be 2 by p. Since 7x minus 5z is defined, so the order of 7x and 5z must be same. But here we have the order of 7x is 2 by n and order of 5z is 2 by p. From these two, the number of rows are already same, which is 2 for both the cases. Since these two things are equal, so n must be equal to p, then only these two things will be equal. So n is equal to p. So our answer is option B, which is the order of 7x minus 5z. In the other options, the order of matrix 7x minus 5z is given, option A is given p by 2, which cannot be possible as the order of 7x is 2 by n and order of 5z is 2 by p. So 2 is the number of rows for both the cases, but from these two we cannot say 2 is the number of columns for both the cases. So option A cannot be the answer. Now option C is given the order of 7x minus 5z is n by 3, which cannot be possible as because here 3 is not given anywhere. 2 is given but 3 is not given anywhere. So the order of 7x minus 5z cannot be n by 3, which is wrong. The option D is given p by n. Since the order of matrix 7x is 2 by n and matrix 5z is 2 by p, the order must be equal to 2 by something, because for both the cases number of rows is 2. Here we cannot write p by n. So the only option we have left with option B, which is 2 by n. The option B is 2 by n. Since n is equal to p, we can write the order of the matrix 7x minus 5z is 2 by n.